started, everybody. Does this thing seem louder? I feel like the mic is louder today. Maybe that will help. I don't know. Who knows? Not I. Yes. Ah, yes, thank you.
Very good, yes. I've got some more direction. Oh, that's excellent.
All right, when you're all finished, thank you. So, last time we finished off our discussion of object-oriented programming, and we are now on to exciting new territory. We are now talking about files, file system interaction, and the interaction with permanent memory structures. Last time, we introduced briefly the idea of the standard input and output files accessible through print and input. And today, we shall be talking about files proper. So, does anybody know what a file is? Easy question. Yes. It holds information, sure, but analog electrical signals also hold information. What's the distinction? Okay. Anybody else want to take a stab at it? Yes.
Is it something that can be read?
Something that can be read, yes. Similar in some way to a book or a file in the physical sense. So let's just talk then briefly about how the heck memory even works. So, all right. So if we take things back to the level of hardware, right? At least this, I'm going to talk about magnetic disks because they're still in use and the concepts are transferable. But the way that hard drives work, magnetic disks, you have a disk which is made of a material which will hold a magnetic polarity, right? You have attached to that a read head, a read-write head, which has a special, an arm with a head on it that has the function of either reading or writing either north or south polarity to the magnetic disk. If you were to zoom or write in on this, you would have a sequence of cells, right, that are either in north-south or south-north orientation, right? You can actually detect whether or not they're in north-south or south-north orientation by whether or not they attract or repel a similar or opposite magnetic polarity, right? So, this is how ones and zeros get encoded on a magnetic disk, right? So 0, 1, 0, 0, 0, or possibly with the polarity flipped, I'm not actually sure. So we have the ability to store ones and zeros inside of a disk which can hold a large number of them, right? One of these magnetic disks, like if you actually ever open up a hard drive and take a look inside, you'll see that there is not just one of these magnetic disks. You actually have like a whole bunch of them, each with its own independent read head, right? You might have like 4 or 5 of them, right? Information can be packed quite densely on these guys, although there are certain physical limitations to the size. At any rate, we have the ability to store sequences of ones and zeros in some kind of permanent medium. So what do we do from here, right? We need some means of organizing the disk in such a manner that these ones and zeros can be put into a particular context so that they mean something, right? What a file is is it's a region of possibly contiguous memory. Contiguous means that it is all in one piece and not broken into small pieces. Actually, files can be broken into multiple pieces. It's a sequence of zeros and ones which have been stored on the disk, right? One of the things, one of the mechanisms by which this disk encodes this information as files is there is a region of the disk called the file table. The file table designates which memory addresses correspond to which files. So if we sort of zoom this out to the level of bytes, right? If we, if we zoom this out to the level of individual bytes, like etc. Each one of these bytes has an individual memory address, right? So this one might be 3,486. This would be 3,487, etc., right? The file table indicates which regions of bytes by memory address correspond to which files, right? So this is a computer. Fundamentally, everything is in binary code, right? Right down to the smallest conceivable thing you could possibly think of. So you have a file table, right? So there's nothing inherent to the memory itself which designates a region of memory as being a file, right? That association is drawn because the file table says so, right? But once you have acquired the correct starting point for a file, you read in all of the bytes that you need until the end of file character is reached, right? That constitutes a file. Everything past that point is interpretation, all right? So a file is a file is a file, right? All files are stored in the same way, whether it's a .png file of a meme that you found on the internet, or the .docx file which contains your essay submission that you're working on tonight, or even if it's one of the web pages that you visit, like Facebook or whatever, or even this set of lecture slides itself. All files are stored in the same manner, and they are all interpreted by different programs to yield different results. This is why am I banging on about this? Files are interpretations of sets of ones and zeros. That's all that a file is. Like, there's nothing magical about a file extension, right? A file extension is just a few characters at the end of a file name which indicates to the program reading that the file should be properly formatted for that program, right? So, if you take, for example, a Word document, it's .docx, right? That, or .doc. They actually follow a different standard. I believe they use XML for Word documents. I know they do for Excel files, right? So there's another means of interpretation of that file, which is called extensible markup language, which Microsoft uses to encode the data that is needed in order to display your spreadsheet, right? But there's nothing magical in the file extension itself. You could, in theory, take an Excel file make modifications in a plain text editor, and then reload it back into the into Excel, and so long as that file still maintains all of the conventions that Excel is looking for, that will still be read and interpreted in the way that you intended, right? So you can modify sort of the source code of the Excel file. It's not really source code, but you can kind of think of it a little bit like source code. So, like, how many here know what a plain text editor is? You at the back, sir. What's an example? The normal one that comes on the computer. What's it called? Text editor. Are you running Linux, sir? Are you, so in Windows, right? Mac? Ah, yes, okay. So text, in Mac they just call it text editor. In Windows they call it Notepad. So all of you who are on Windows at the moment, I'd like you to all open Notepad and take a look at what it looks like, right? You can have different types of plain text editors which they help you program in a certain way. Like there's a program called Notepad++, which will do syntax highlighting for you. But in general, the purpose of a plain text editor is direct modification of the ones and zeros which constitute the file. The only interpretation that a plain text editor does is to assume that the file has been stored in ASCII code or Unicode or whichever encoding format. In other words, all you're doing is you're viewing the sequence of ones and zeros as characters, right? And tabs are tabbed over and spaces aren't displayed but the space is left, and all of the beautiful things that make, binary code legible to human beings, right? But this is like the GetIt program, right? This is just a plain text editor, right? So if I were to find a file which is suitable for such a process, like this PNG file, I can open a PNG file in a text editor, right? I need to actually open that. There we go. So it gives you a warning because it feels like this should be invalid characters, right? And, it looks kind of invalid, but, we're just going to edit it anyway. So this is the data that constitutes the image, right? This is not interpretable easily by human beings inside of the text editor environment for the simple fact that all the characters are essentially random, right? And the reason for that is image files don't generally group, they don't group things by character, they do it by like pixel. So it's like you have an alignment problem, not to mention, pixel values don't necessarily make sense as characters. That's why you have like, friggin' this character, it's like you just so happen to land on this character when you interpret it as Unicode. But yeah, so you can use a text editor to view the data of any file that you may wish to view, or any file on your system, even the complicated ones. Yeah, so you can do this with Notepad as well, right? If, on the other hand, let me just see if we've got something which might be a bit more. Yeah, well, anyway. So anyway, the thing that I'm, like, the reason I'm telling you all of this, the reason I've been banging on about this so much, I really want to reinforce that there's nothing special or magical about file extension. You can invent your own file extensions. People do it all the time. You don't have to go to the, you don't have to go to the little box with the red LED on it, that's the internet, and register your file extension or anything like that. If you write a program that requires files, and it expects them in a particular format, which is unique to your program, that gives you every right to decide what file extension should be for it. Normally, if it's a save file for a video game, it's .sav, like you pick something mnemonic, right, so that you can tell what it is. But yeah, there's absolutely nothing about a file extension that that designates it as all it is just a label, right? Now, your operating system is trained to look for the label. If you double-click on a file of a particular extension, the operating system keeps a registry of the particular programs which which are intended for various file extensions, right? But that doesn't denote exclusivity, right? Anyway, so yeah, files. I guess this is a long-winded way of saying that because we are now programmers, we have the ability to pull any file out of the file system, make modifications, write files back into the file system. The world is our oyster. We have free reign to do anything we want, anywhere we want. With the, of course, with the caveat, and of course this caveat applies anyways to non-programming things. If you mess up your file, your operating system's system files, you're going to wish that you hadn't, and probably have to reinstall everything. So, be careful, but you can do pretty much anything you want. Like, for example, it is 100% totally possible to open a Excel file, an Excel spreadsheet in Python, get the data out of it, write data back into it, save it, and then you can interpret it in Excel again. That's actually a really useful thing to be able to do, because, while Excel is a very nice program, and its macros are actually very powerful, and all of you should have a leg up on being able to do macro programming in Excel now that you've learned some Python. One of two things. Either Python does something that is difficult in macro programming, or you're just more comfortable with Python as an environment, so it'll be faster for you to do it in Python. Either one of those are excellent reasons to import that thing into Python, right? Am I making sense? Good. So, here is your basic procedure for working with files. Now, this is not Python specific. Pretty much any C-based language is going to operate on files in this manner. In fact, I have yet to encounter a programming language where this is not the basic procedure. It has, and the reason for that is it doesn't really have to do with the programming language per se. This is more how you interact with an operating system, right? So anyway, number one, you will have an open command. You must open the file. In order to open the file, you must know where within your computer's file system the file is located, right? You can use either relative or absolute addressing. You guys know what I mean by absolute and relative addressing? No? Okay. Brief tangent. In a lecture that's already filled with brief tangents that aren't so brief. So, inside of your file system, right? Let's talk to the Windows users for a moment. How many people are Windows users here? All right, how many people are Mac users? Okay, so Macs will follow Linux's convention, which I might talk about briefly as well. So, C:// right, in Windows. That's, by default, your hard disk. This is a directory, but it's the top level directory of your file system, right? Within that file, within that directory, you may have, users, me, documents, and then the file .txt, right? Something like this. You'd have other branches, obviously, as well. Otherwise, you wouldn't have a computer, right? You'd just have a hard disk storing one file in like 4 directories. Anyway, so absolute addressing means when you address the file, you include the entire path to it, starting at wherever the root folder is. Incidentally, in Linux, this is called slash, right? In Linux, it would be /home nic /docs /whatever, right? So that's absolute addressing, right? It's absolute because it doesn't matter where the calling program is located inside of the directory or inside of the file system hierarchy. You always have the exact path to the file you're looking for, right? So that's absolute addressing. Relative addressing, on the other hand, is relative to the current working directory. So when you launch a program, it is considered to be running inside of the directory in which the executable is contained. Now, this is not necessarily always going to be true. Programs have the ability to change their own working directory, right? Often they don't, because it's just like, unless it's for a specific operation, you might like jump into a subdirectory, do some stuff, then jump back up to the main directory. But in general, you can assume it's a fairly safe assumption that whatever the directory that the executable is located in, that'll be the current working directory for that program, right? So let's say I've got programs as a folder, and then inside of that I've got my prog, right? Inside of that we've got a data folder. Inside of that we've got slot1.save, right? Let's assume that my program, the folder my program, also contains the executable file my game, right? My program, I'm just going to put that there, my program will be the current working directory when my game launches. When you specify, if you're programming this game, when you specify, I want to open the file slot1.save, you don't just say slot1.save. You use relative addressing and you say data slash slot1.save. Whether it's a forward slash or a backslash will depend on whether you're using Linux or Windows. Windows does it wrong. I'm just putting it out there. In the entire history of computing, everybody has used the correct slash, which is the forward slash for this type of operation. Windows literally, like when they were programming Windows, they literally made the decision to use the other style of slash just to be different from Linux. Just to be different, well, Linux didn't exist back then, but just to be different from Unix. That was literally the only reason. So thank you, Microsoft. Thank you, Bill Gates. While I'm sure all of us appreciate your philanthropy that you exercise in later years, I wish you had given us a little more philanthropy when you were laying the groundwork for freaking Windows. But anyway, so you use absolute or relative addressing. You can use either without having to specify an option. If it's absolute addressing, it knows that it's absolute addressing by the address. Whereas if it's relative addressing, it knows that it's relative addressing by the address. All right? Is that clear? Is everybody cool with that? I'm basically teaching you how computers work right now, you know? I know we haven't gotten through many slides, but I feel like this is still very important information. If you didn't have it already, which it seems like a lot of you didn't, so good. Anyway, so the procedure. You open the file. This creates what is called a file handle, or in some cases, a file stream. You'll hear the two terms used interchangeably, file handle and file stream. The operating system only allows one program to open any particular file at a time. This is an extremely important part of what it means to be an operating system, right? This is to prevent what we call race conditions. So let's say we had program A and program B using file C, right? Both of these programs want access to file C, right? What actually happens is the first of these two to request opening file C forms a lock on it, which file B can't penetrate because the operating system prevents it, right? Once, where's my shot brush? There we go. So, once A is finished with file C and performs the close operation, that releases the lock that the operating system has on that file, and it may be opened and read by other files, right? In the in-between bits, you're either reading or writing the file as you will. So, we also can't read and write a file at the same time. They are different procedures. At least at this level. There are technically ways of doing it, but let's just keep it simple for now. So the reason that you would want this, right? Let's imagine a scenario in which program A and program B are both allowed permission to write to file C at the same time, right? Let's say program A on line 10 says yes. Let's imagine program B then writes to the same line and says, no. And let's imagine that this happens very, very quickly, within a small fraction of a second, right? The state of the file is dependent on the order in which these two programs are performing their operations. This is a drastically bad thing. What it can lead to is inconsistent states within this file. So let's imagine that we're talking about something a little more, a little more complicated than just writing one line. Let's say that these were two instances of a Word document that were both modifying the same, that both had open and were modifying the same Word document, right? Let's say user A, who is operating program A, writes a paragraph. Let's imagine user B writes a paragraph as well. Whoever is the last to hit save gets their paragraph saved. The other person gets it deleted, and they don't know that until they've opened the file again. This is what's known as a race condition, because essentially user A and user B are both racing to be the last person to write to the file, and they don't realize that they're in that situation. So this business of the operating system locking out access to the file is essential for the correct operation of the computer. Google Docs notwithstanding. So if you want to know how Google Documents handles the parallelism, right, with having multiple cursors, right, it's actually kind of clever. Rather than like making direct modifications to the file itself, your instance of like Google Sheets or whatever, like the spreadsheet one, right? Your instance of that, it's not directly modifying a file. What it's doing is it's sending commands to Google. Google then parses commands from several users at once and updates the file accordingly. It looks a lot more like a databasing operation than an actual file write operation, as it turns out. But anyway, so this is the procedure. You open it, you modify it or read it, then you close it. Closing it is very important because if you don't close the file, when you're finished, the operating system maintains the lock on it, at least for the duration of the program that opened it, right? So, if it's one of these little toy examples that we have where, like, you open it at the beginning, you close it at the end, and you do nothing in between, that's one thing, right? Like, the operating system knows that if the program that opened the file itself closes, then everything it has had access to should also close. But until such time as that happens, you risk not being able to access files because your own program still has a hold on it. But anyway, so it's just very important. It's like a hygiene thing. Always close your files after you finish with them. And you're not necessarily used to the idea of closing files anymore because a lot of the blasted user interfaces that everybody is using these days, basically when you close the program, it automatically closes the file for you, right? How many people close the file before they close the program? Like one person, maybe? All right. I'm surprised. Anyway, so the code for opening a file in Python. You create a file handle object by invoking open myfile.txt. This is the file name, absolute or relative addressing. You then have a string which indicates the mode. The mode must be declared up front. In this case, we are entering read mode, right? String is equal to filehandle.read. Filehandle is an object. All of the all of the operations which we perform on files will be methods of the file handle or of some other library object. We can then close the file handle, having obtained from the file what we desire. We can then print the file contents, because the file contents have been loaded into Python as a string object in Python. So everything we have learned so far about working with and modifying strings and displaying them and everything else is applicable to the contents of the file after this operation. So you know, like split on space to get the words out, you can do that, you know. Slicing operations, you can do that. Literally anything that you do to a string, you can do to this file. However, it's also important to note, modifying this string does not modify the file itself, right? In order to, if you want to modify the file itself, you first load the contents of the file into the program, make the modifications you want, and then you have to perform another another open-close operation to write those contents back into the file. Now, most often, you will just overwrite the existing contents of the file with the new contents. That's the most straightforward way of doing it. You can also append, but that's kind of beyond what we're going to be talking about in this class. So, you want to see a demo? Let's do it. So, I don't want slides. I want teaching. This class, this semester, our example folder. Get it? Topic 9.py. So, file handle is equal to open. Let's just say topic 4.py. File string is equal to file handle.read. We can then file handle.close. Print the file contained, and then we can print the string. Python 3, topic 9.py, and you can see this is what the file contains. If you want, you can do other kinds of stuff like .split on the new line character. That's a useful one. Each line of the code separated out into a separate string inside of the list. Right? Let's say, let's have a little fun. Let's say s is equal, let's say contents is equal to s.split, and for line in contents, if line line at 0 is equal to the comment character, then I'm going to keep a different one. Contents 2 is equal to 2. If this is not true, then contents 2 plus equals line. There we go. Now let's just print that for line in contents. Print line. Let's see what that does. File error. Oh, string index unarranged. Oh, right. If length of line is equal to 0, continue. Now, I thought that should get rid of that. I'm printing the correct thing. Did I make a mistake?
I'm wondering which people line of contents too.
Oh, yeah, that would do it. Thank you. Yep, it's always something like that, right? Yeah, there we go. So, this is the same file, but with every line that was a comment, or at least with a comment character starting as the first character of the line, and all lines that had nothing on them removed. These lines must have like at least one space character, right? Now, let's do one more. Let's write this back, right? So, file handle, file handle is equal to open. Let's say topic for.py.new, because you can just invent file extensions. Put this in write mode. For line in contents 2, file handle.write line fh.close. Run it again. Invalid syntax. Yes. Okay, thank you. Thank you very much. There we go. So you will notice topic4.py.new has been created. You'll also notice that the operating system no longer recognizes it as being a Python source code file, despite the fact that it is, right? It no longer gives you the Python symbol, right? It's just, that's the symbol for a plain text file, which incidentally is the same as if you don't put any file extension on it at all. So, if we open this guy up, which by default opens in a text editor, you'll see that it screwed it up a little bit. This is very common in file operations. Let me just modify the original program ever so slightly. fh.write new line character. There we go. Try that bad boy again. Reload, and there we go. Boing!
That's simple.
Answer.
I said that's simple.
Yeah, like, think of the applications of this, right? One common application, one thing that I commonly use teaching these very classes, your grades are stored in Avenue's database in whatever format they want, but you can export it to a type of file format we're going to be studying called a CSV file, comma, separated value, CSV file. Basically, plain text spreadsheet. The formatting that Avenue uses is it's particular to Avenue. And Mosaic expects something else, right? Don't even get me started on the fact that the people who programmed Mosaic didn't look at what Avenue output and said, hey, maybe we should make our program compatible with what what is output by the frigging learning management service that's used by the university, but anyway. So I have a Python script which loads up the CSV file, configures and modifies the values, and then puts them into another CSV file which is understandable to Mosaic, right? And thereby I can upload the grades of literally like any number of students. I can get that operation done in 5 minutes using a script. Whereas if you did it by hand, you would have to, it would take, it takes at least 10 seconds to enter one grade, right? If you're working quickly. And, the amount of hassle it is to enter grades scales with the number of students. But if you do it with scripting, it doesn't, right? Technically it does, but it does on a scale of microseconds, so you don't care, right? It turns out that a large number of routine office tasks can be automated in this manner, right? Pretty much any data entry task that you might have, it's probably going to be faster for you to figure out how to write a script to do it than to actually do it even once. And once you have the script, you don't have to ever think about the problem ever again because you have a script for it, right? But yeah, and once you figure out that you can also get Python to send emails, man, then you're off to the races. But anyway, so yeah, the applications of from a practical perspective of making you a valuable asset to a company or to yourself with programming skill, file handling is probably one of the key skills that you should take away from this course. So, so let's go over some of the functions that we've just used, right? So, open opens file name and returns a file object, file handle. Mode specifies the mode, obviously. R for reading, W for writing, A for appending. What's appending again? Anybody? Append, yes? Adding to the end of, yes. So it's like a writing operation, but it adds to the end of the file rather than overwriting the existing file. Keep in mind, writing will overwrite the existing contents of the file. So if you want the file preserved, you should write it to a different file or append. Good. FileHandle.read reads the entire file to memory. That is to say, random access memory, not read-only memory, and returns it as a string. Puts it into Python's working memory, saves it as a variable. FileHandle.readLine reads the next line into memory and returns it as a string. This string includes the new line character. So you have the option of reading either the entire file all at once or reading it line by line. Personally, my preference is to do it all at once because I'm the guy who cooks his bacon on like 7 on the stove. It's like, get it done, you know? But if you want to go line by line, then that's perfectly acceptable as well. You have the tools. So, and then of course, FileHandle.close. Closes the file and frees the resources associated with the file object. And since we talked about, I've basically done these, not quite, all right. So, one of the things that I ran into with the demo that I gave you, you can for loop over the contents of a file handle, right? That counts as reading it. If you do that though, each line will be absent the end of line character. If you try to put it back together again at the end, you'll have to include the new line character again, as I had to, right? But if you know what a new line character is, does, and why it's useful, this should be no impediment. You can also use the rstrip method, or right strip, so it strips one element off of the right. You can use that as well, if you want. Or, oh no, I'm sorry. We'll include the underlined character. Sorry, I got that reversed. So it is in there, so you don't need to add it if you use this method. Good. So, if you try to open a file that doesn't exist, you will get a file not found error. One thing that I like to commonly put on exams and tests, that should be the ears perked up, everyone. Oh, the ears are already kind of perked up as the masks pull them forward, right? But anyway, one thing that I commonly ask people to do on tests is write a function that takes, the function will take as an argument the file name of the file that we want you to process. And if opening that file fails, we say, okay, assume that the file extension was left off, modify the file name, try to open it again. If it still fails, then it's really failure, right? You can handle file not found errors. All right? All right, I think that's everything that we can usefully cover today. Thank you. Jeez. Get out of here.